Have you ever wondered what makes a rocket fly, or how these magnificent machines, capable of reaching the stars, are built? Today, we'll delve into the intricate world of rocket components, dissecting these marvels of engineering layer by layer. First, let's talk about the structural components. The payload is the heart of any rocket mission. It's the valuable cargo that the rocket carries into space. This could be anything from a scientific instrument to a satellite or even a spacecraft. The fuselage, or the body of the rocket, is the main structure that houses all the components. It provides the necessary structural integrity to withstand the immense forces during launch and flight. Covering the payload, we have the fairing or the shroud. This protective shell provides aerodynamic smoothness during ascent, cutting through the Earth's atmosphere like a knife through butter. Now let's move on to the propulsion components. The star of this section is the rocket engine. It generates thrust, the force propelling the rocket upwards by burning propellants. These engines can come in different flavors: liquid-fueled, solid-fueled, or even hybrid. Closely associated with the engines are the fuel tanks. These store the propellants that the engines burn. Next up are the guidance and control components. The avionics, a combination of electronics and computer systems, guide the rocket on its course. The gyroscope, or the inertial measurement unit, IMU, are crucial for maintaining the rocket's orientation and stability during flight. And then we have the thrusters, or the reaction control system, RCS, small rockets used for fine adjustments of the spacecraft's orientation. Aerodynamics play a vital role in rocket design. The nose cone, the pointed top of the rocket, reduces air resistance during ascent. The fins or control surfaces also contribute to stabilization and control, especially during atmospheric flight. Rockets often have multiple stages, each with its own engines and fuel. Stages separate during flight, discarding spent components to reduce weight. This brings us to the separation and staging components. Separation systems ensure clean and safe separation of stages or payload fairings during flight. Last, but certainly not least, we have the other essential components. Heat shields protect spacecraft against extreme temperatures during re-entry to Earth. And then there's the electrical systems, the wiring, batteries, and power distribution systems that power everything else. Each part plays a critical role in the successful launch, flight, and sometimes re-entry of a rocket, ensuring the safe transport of payloads to their intended destinations. Through the combination of these components, we can reach for the stars and beyond.